So in this video I want to show you how to build a backfire antenna. Now the backfire antenna is an antenna that's been around for quite some time, but it tends not to be so popular with hobbyists, and I first came across this antenna probably back in 2002, but I never got round to building one because I didn't see that it had any overall benefits than say the humble biquad antenna. It just seemed to me that it was a biquad antenna with a kind of a flat dish reflector. But what I've been doing recently is experimenting a little bit with the backfire antenna and experimenting on the main driven element to use with the backfire, because there are quite a few different variations out there, and here are some of the driven elements that I've been experimenting with here in the lab. This is a more traditional one, either in the horizontal or the vertical position for the driven element there, but these are circular polarized driven elements, and I've recently built a small prototype using one of these kind of driven elements, and it does actually seem to be a good antenna, and it's got a lot of promise. So I thought I'll do a quick video to show you how to build one of these, especially for the circular polarization, because I know that's quite popular out there with the quadcopters and everything else. But I do want to build a more linear one, say on a biquad main driven element or something similar. This one is the more traditional dipole driven element, and here we've got the Ballon, because with this kind of driven element we need a Ballon. This is a simple Ballon where it's a quarter wavelength, and I've just wrapped it around the central tube there to make it tidy and put it out of the way a little bit. But also what's interesting with this particular antenna, we've got these two discs on here. Now if you've seen quite a lot of my previous videos, especially the Yagi antennas, then what we've actually got going on here is a bit of a hybrid, because these are acting as parasitic elements similar to how they would act with a Yagi antenna. So it is a bit of a hybrid antenna when you look at it more closely. So I've got a finished prototype here that I've been playing around with, and I've made a few changes since I've built this one as well. Mainly changes to bring down the VSWR. I've played around with the distances between these discs, for example, and you may notice here on the driven element they're kind of pitched up a little bit, the elements themselves, but I found I get a better result if they're flat rather than at an angle like this. But basically this is the outline of a backfire antenna. We've got this big dish, flat dish reflector at the back here, which indeed is a Victoria sponge cake tin that I purchased off eBay, and the cake tin itself is 20 centimeters in diameter, and you know, it's quite a simple antenna to build, especially if you're used to building the something like the crosshair antenna, because the main driven element works in much the same way as the crosshair antenna to get its circular polarization. So what I'll do then, I'll start off by building the main driven element, and then we'll move on to building the reflector itself and putting the antenna together. So to make the driven element, I've got this copper wire here. It's 1.6 millimeters in diameter, and I've also got one of these telescopic aerials, and we're just going to use this for the tubing itself. I picked this up from the pound shop. You can pick them off eBay for a similar price. The Coax, you can either use the semi-rigid stuff or the more traditional stuff. I've also got some copper tape here. Now if you take a look at these two driven elements, one I've actually filled in the elements here to make them quite solid, whereas this one it's left open. The difference between the two is this one is a little bit more broadband, so it works over a slightly wider area of the spectrum, but it can also handle a lot more throughput. So if you're streaming video at quite a high resolution, you'll probably find that you're better off with this one rather than this one. But again, it's just preference, how you want to build this antenna. You can experiment and build one of each if you like, but theoretically this should handle a little bit more throughput over that data stream. So I'm making the driven elements first. Now there's two different lengths for the driven elements. There's a longer one here which is 31.25 millimeters, and that's from the top of this bend here all the way back to where it's soldered onto the coax. And same with the shorter one. The shorter one is 27 millimeters long, again from the top of the bend here all the way back to where it's soldered onto the coax. So what I'm going to do, I'm going to make the longer ones first. I'm going to measure off a length of the copper wire at 75 millimeters long. Then I'm going to put a little mark roughly in the middle, bend it around my piece of wooden doweling, and then when I've got it all soldered up, I'll cut it down to the appropriate length then. So to start off with then, roughly about 75 millimeters long, and I need two of these. And as for the shorter ones, if you measure off two lengths at around 65 millimeters, that should be fine. So next I'm going to put the bends in the middle of my elements here. So I've put a mark roughly in the middle of the copper wire, and I've got a piece of wooden doweling here that's 6 millimeters in diameter. Now the diameter is not much of a major concern. You can actually play around with this a little bit, make it a little bit smaller or a little bit wider, but I've got 6 millimeters here, and I'm just going to carefully bend it nice and evenly around that wooden doweling so the ends will meet up. And you can also put it on a flat surface and just give it a little roll like a rolling pin, just to get it nice and smooth and even in that bend. So once you've got your bends in there, you want to now manipulate the two legs here to bring them into this kind of a teardrop shape here, or propeller shape if you will. So best way to do this is with copper. If you slowly manipulate it, it kind of gets quite soft. So if you don't try and bend it all in one go, you get a much better bend. So I'm pinching it in here at the top and just working it down in between my thumb and finger until those two ends start to come together, but I still want it to lay flat, so I don't want it to cross over yet. So next I'm going to prepare the copper tape to solder onto the elements, and as I pointed out, you don't have to do this step. You can leave them just as they are, like this one here, but I'm going to show you how easy it is to solder this copper tape. You've seen me use this a lot before in previous videos, and this I have picked up from the garden centre. It's slug repellent tape, and it was 99p for a metre, so it was cheap as chips. And what I'm going to do is sticky back. I'm going to peel the sticky back off, and I'm going to double it up, so I'm going to stick each side to each other to make it twice as thick. So next I'm going to flow some solder onto here just to make it easier to solder onto the elements themselves, and also add a little bit more strength to this. So I've got it taped down at both ends, and it really is simple. It's just like painting the solder on this tape. It really takes the solder well. So next you want to tin up the elements on one side just to make it easy to solder it to the copper tape. And next I'm going to solder the elements directly onto the copper tape. So I've got the elements solder side down, making contact with the tape, and I've got a wooden dowel here just to help put a little bit of force down onto that element. You don't want to use anything metal because it'll act as a heat sink and draw the heat away, but a little bit of solder on the end of my iron, and again just apply some heat just to get that solder flowing. And once you've got it tacked down onto the tape, flow a little bit of solder on the inside, but kind of try and do the top first, let it cool down, and then do the bottom half. And now that we've got them soldered on there, what I can do now is just simply cut them out with a normal pair of scissors. So here are the elements now that I've trimmed all that excess off there and tidied them up at the sides with the file there. So what I'm going to do now is measure them off to the correct length. So the length of the longest element wants to be 31.25 millimeters, so about there should do it. And the measurement for the short elements needs to be 27 millimeters long. So next I'm going to solder the elements together now. What I've got here, I've got a long one and then a short one, and I'm going to make this left-hand circular polarized, although we can change our mind when it comes to soldering the elements in place. But I'm doing it this way, the long one here and the short one there, and I will solder the other elements the same way. So we've got a long one and a short one, so they all match up this side up. But as I say, we can change our minds when it comes to soldering them in place on the coax. Now to solder these two together, I'm going to use the same method as I used to cover the elements in here, and so I'm going to use some of this copper tape again. I'm going to use a small square, I'm going to double it over again so it's twice as thick, and put it underneath here and flood some solder in there. So what we end up with is a little solder pad that connects both of these two elements together. So I've taped the elements down, and you want them to be at a right angle to each other. You don't have to measure that, but I've just taped it down so they can't move anywhere, and just eyed it up there on a right angle. I've got a little square of that copper tape, and I've already pre-flooded it with some solder there. So what I'm going to do is slip it under the elements and then solder that in place, and it should do a good job of holding these two together. And of course I'm going to flood a little bit of solder over here as well. So it's just a matter of getting some heat in there and feeding some solder in. So they're the two elements finished, so I'll put them to one side and we'll move on to the preparation of the coax and the Ballon for this antenna. So I'm going to use semi-rigid coax for this antenna, and I've got 100mm length here, and I've cut away some of that outer braid to expose 10mm of the inner core there. So what I'm going to do now is cut a small trench about 10mm long in the side wall of this outer braid here, and I'm going to solder on a short length of this thin copper wire, similar diameter to the inner core of the coax itself, just so we've got two rigid pieces of wire that we can bend over then to solder our elements directly onto. It just makes for a stronger build if you do it this way. But I'm going to use my Dremel, cut a small trench in here and solder that into the trench. So that's the coax now prepared, so I'm going to move on to creating the Ballon, which this is going to fit inside of. So to make the Ballon, I'm using a 35mm long piece of the widest tubing off one of these telescopic antennas. The tubing is 5mm in diameter, and what I'm going to do, I'm going to cut a slot in the side of this tubing at 1/4 wavelength at 31mm. So I've got the tubing held in this vise just so I can get the cut as straight as I possibly can, and also the tubing does get a little bit hot when you start cutting it. I've also covered it in some masking tape just so you can see the black line a little bit better when you're cutting, and on the Dremel as well I've doubled up on the cutting wheels to make the cut a little bit thicker. So that's what the slot looks like. So I'm just going to remove the masking tape, get a small file and tidy it up a little bit. So that's the tubing prepared for the Ballon, and this works the exact same way as a slot antenna. So basically it's the same kind of Ballon as this one here, just that we've cut a slot in it instead of having the piece of dangly coax. So next I'm going to insert the coax so we can complete our Ballon. Now this outer pin here, the ground pin on the coax that we've soldered in place, I only want this part of the coax to come into contact with that metal tubing. We're going to solder that in place. So I'm going to have to isolate all this from the tubing with a little bit of a heat shrink tubing. So I've got the Ballon in place, but I haven't soldered it onto the ground yet of the coax. But I just wanted to show you the signal wire there. I've just got the Dremel and just ground a little bit away from the edge of that tubing there, just to make doubly sure that that signal wire doesn't ground back down to that Ballon. So I've got a nice gap there that you know, hopefully I won't be shorting the antenna out. So what I'm going to do now is flow some solder onto that ground wire there, and I've already pre-tinned that edge of the Ballon up just to complete this Ballon and the coax feed itself. So that's the Ballon all finished and soldered up. So let's move on to preparing the reflector for this antenna. So for the reflector then, I've picked up two of these sponge cake tins off eBay. Didn't cost a lot of money, just a couple of pounds, and this is a 20 centimeter sponge tin. So what we're going to have to do then is drill 3 holes in this tin here, one directly in the middle and 2 either side. Now you want one in the middle for the coax and the connector to come up through, and then we can solder our driven element onto there. And we also need 2 holes at either side of that for these supports here that support the little directors there, the parasitic elements of the Backfire antenna. So in order to help you to do that, I've made this template. It's just got the 2 directors here, the 2 round parasitic elements, and the drill holes where you need to drill into there to connect them all up. And same again with this large circle. I've just been working off the 20 centimeter standard because it seems to be a standard on eBay for these cake tins, so it shouldn't be hard to find. So what I'm going to do is cut this out then and then stick it on, and I can use this to direct my drill bit to get the hole directly in the middle and the 2 spaces either side. So as you can see, I've got the 3 holes drilled here, one slightly larger in the middle to fit the tubing of the Ballon through. So I'm going to solder this now directly onto the back of the reflector. So I've cleaned up around the Ballon here, and I'm going to solder it so the very end of that slot, that slit we've cut into the Ballon, is just on the edge of the back reflector here. So we're going to have a little bit of this poking through on the other side, and I'm just going to flood solder all the way around here, and then hopefully we'll get a good connection to the reflector. So it's all soldered in place nice and secure now. I've got it soldered on this side of the reflector and on the inside of the reflector, and what I've done now, as you can see, I've got those 2 lengths of the coax wires that this one I soldered on, and this one is the center signal connector, and I've bent them around into this hook shape because we're going to solder on the driven elements now that we've previously made. Now this one that I'm making in the video is going to be left hand circular polarized, and how you work out the polarization of this particular antenna is the same way you work out the polarization for the crosshair antenna. So you start off with the signal wire, that's the center of the coax, and this is going to be your lead. So if you want it to be left hand circular polarized, you start off with the longest leg first. So this will go in on there and hook on there. So we're leading off with the longest leg on that center connector, and then we're going to short, and then we'll put the other element in place, and it'll go long, and then it'll go short again. If we want right hand circular polarized, then we just do the opposite. We lead with the short leg first on the signal wire. So I would put it this way around, hook it on that hook again. So this time we're leading off with the short leg, long leg, and on the opposite side, short leg, long leg. So that'll be right hand circular polarized, but this one's going to be left hand, so we're going to lead off with the longest leg first. So the method of using these little hooks makes it very easy to attach the elements to, also makes it pretty strong as well. So I've got the element there, and I've got it at the right orientation that I'm happy with for left hand circular polarized. And what I'm going to do now is take these pliers and just nip that hook together, and then I'm going to flood it with solder so we've got a really good connection. So the elements are hooked on there, and you want to get the gap in the middle as close as you can without them shorting out to each other. So I'm just going to flow a little bit of solder in this area here, and again, I'm not going to keep my soldering iron too long on there. I don't want the heat to spread all the way through, otherwise the soldering that we've done to connect these two elements together will fall apart. So it's just basically get some heat into the wire of the coax itself and just let it flow down a little bit, then remove your soldering iron. And then just do a final check to make sure that they're not touching, and then I like to get a little bit of epoxy putty, just work it in there just to make sure that it's really is secure and there's no chance of those touching again if you accidentally drop this, for instance. You can also use a little bit of epoxy glue as well. So while the epoxy putty is setting on those two elements, you want to make the round parasitic elements for this antenna. Now I've included this template here that you can download, print off, and then cut them out and stick them to either some tin, cookie tin, or the top of a baked bean can, for instance. You can use PCB here. This is an early prototype when I was playing around with the sizes. You can make single layer PCB. I've made mine out of some brass because I had some brass laying around, so I had some offcuts, so I've made them out of brass. But basically anything that's metallic you can make these from, and also take into account how easy they are to cut out. I use tin snips for the brass, and I also use tin snips for the PCB here. But if you're using something as thin as a cookie tin, you could get away with using scissors, but just be careful because you can get sharp edges when you cut them out. Now you're going to need something to stand your discs off on. Now I've got these hex spacers. You can pick these up off eBay. The longest one is 70mm. I didn't quite have one that was 70mm in length, so I made it up with two here to get the 70mm, and I've got two here at 40mm. I've been playing around with the different distances, and so far this gives me the best VSWR and gain, so this is what I'm going with. But again, when I experiment, I may change around with those distances, because as I said at the beginning of the video, it's very similar to how a Yagi antenna works with these two parasitic elements. So I've done a lot of work over the last couple of years on Yagi antennas that I wasn't originally into a couple of years ago. But knowing how a Yagi works, this is the distances that I've come up with, and they seem to work best at the moment. But again, I could change them in the future. So here's the finished antenna then. I've also put one of those little right angle brackets on there and tapped it out so I can attach it to a tripod. But basically it's finished. So what I'm going to do now is break this part of the antenna back down again. I'm going to put some paint on this part, and then we'll give it a quick test in the lab here just to see how well it performs. So just before I do a test over the Wi-Fi, just giving it a quick scan here in my lab, which of course I'll lose a few dB because this is circular polarized, and the majority, if not all, of the Wi-Fi access points are going to be either horizontal or vertical. I thought I'd just show you the SWR here. And originally when I first started building this particular antenna, and all I had to go on was some of the descriptions and blogs on the internet. I was getting a really poor VSWR. It was something like 2.4. It was extremely high, but this is what it is now, and I've managed to get it down to 1.0.3, fluctuating at 0.4 there, but that's due to the reflections in my lab, because it's not testing in ideal conditions here in the lab. I get a lot of reflections off the walls, but hopefully I'm going to be building something soon that maybe will help sort that out. But that's the VSWR, really good VSWR, and this is the antenna here on my bench, testing it, and as I say, the best I've got it at since I started building prototypes of this over the last 3 weeks, so I'm really pleased with that. So a quick scan then, just to see how well it does picking up the local access points as a Wi-Fi antenna. Loading up pretty quickly. I'm liking all that green colour. So that's not too bad at all. The colour there, all that green, really good strong signals across the board. It's actually quite impressive. And it's impressive as well when you remember that this is a circular polarized antenna, and the majority of those access points that are out there are going to be either horizontal or vertically polarized. So when you've got a mismatch, the the circular polarized antenna has got a disadvantage straight out of the gate, because there's going to be a 3 dB loss with the mismatch of the circular polarized antenna, so that's not too bad at all. We'll give it a bit of a turn as well, see if we improve any of those signals, but to be quite honest with you, that looks really good. So I think this design of antenna has got a lot of potential. As I said, I put off building one of these for quite a few years when I first came across this, because I didn't think there'd be much difference between, say, this and a biquad. But having now taken the time to build and test one, I'm a little bit surprised how powerful it really is. It it really does drag in those Wi-Fi hotspots, and as I say, it's kind of got one hand tied behind its back from the get-go, because you do have a 3 dB loss straight away with the mismatch of the polarization. But I don't think it was too difficult to build. A little bit more time possibly than building a biquad, but certainly well worth building, especially if you want that circular polarization as well. So I think as a potential long-range FPV antenna for 5.8 GHz, it's got a lot of potential, especially if the 5.8 GHz version performs as well as the 2.4 GHz version. And yes, I will be making a video next on the 5.8 GHz version. I just need to find something to make the reflector out of, because it needs to be just slightly less than half the size of this. So I'm looking for something around 10 centimeters to 8 centimeters in diameter for the reflector. And something else I'd like to explore as well is instead of having a flat reflector, if I could put a parabolic reflector in there, just to make the most of the reflected RF, because as I've mentioned previously in videos, when it comes to some serious range, you just can't beat the power of a parabolic reflector. So I hope you enjoyed the video, and if you did, please give it a thumbs up as always. Any questions or comments, drop them below and I'll do my best to answer them, and hopefully you'll join me on the next one.